Hi, today we're going to be looking at relating graphs to events. So when we're relating graphs to events, you have already been working with equations and inequalities, and so now we're going to be learning about functions and specific characteristics of those functions. Remember that the word function is a fancy word for an equation. So one of those characteristics is going to be their graphs, and in this section we're going to focus on their graphs. And it also says it's an introduction for relating graphs to events that will later lead to understanding functions. Okay, so let's go ahead and take a look at example 1. In example 1, it says a shoe store is having a sale with each additional pair of shoes purchased at 50% off the first pair, and there's a limit of 4. All shoes are priced at $80. Make a table showing the cost of 1 to 4 pairs of shoes. So it says here the total cost depends on the what? Well, right now we're going to fill this in. The cost is depending on the number of shoes. So let's fill that in. Number of shoes that you buy. So then the dependent variable, y, is the cost, because it depends on the number of shoes. And the output is the y. The x is the number of shoes. Why? Because that's what's changing. It's the independent variable. It's what's changing in my equation. The number of shoes is called the independent variable. Whatever is the thing that's changing and therefore ends up affecting something, that's going to be called your independent variable. So in this case, the number of shoes is what can change. I can buy 1 pair, 2 pairs, 3 pairs, 4 pairs. And what it ends up affecting is the cost of the total of whatever I'm buying. Therefore, the cost is a dependent of the number of shoes. So sketch a graph that represents the situation, label each axis, and indicate the units. If you notice, before they graph it, they made an equation where they had x as the number of shoes, and then they created a table where they found the cost for each one, since they gave us these numbers. So the first pair is $80. Then the second pair, since they're getting half off the second one, it's only plus 40 more. And then the third pair is only plus 40 again, and then plus 40 again. So now we're going to use these points. They wrote them as points now. 1, 80, 2, 120, 3, 200, and 4, 240 to make our graph. Okay, so if you notice, now here we have a graph, and I'm going to just erase this so we can see what's going on. What's going on with this graph. Okay, so here it says, notice that the points are not connected since shoes can only be purchased in discrete units. So you can't buy half of a shoe, right? So that's why they're saying that we can't connect the points, to make a line, because you can't say, oh, I'm only going to have 2.5 shoes, please, okay? So that's why we made it separate, and we plotted each of those points. So this is the graph that matches the table that we came up with. Now it says, also notice the multiple representations this relation was presented. First, they presented a word problem, which was the shoe problem, what was happening. Then they made a table which had input values and output values. Input values is the x. What am I entering? So what's changing? In this case, the number of shoes. Output values, where's my y? which was the cost, the total cost of what I was buying, and then they had ordered pairs, and then lastly we had graphs which had independent variables and dependent variables. These are all representations that you should be able to make either from a word problem or from a graph or from a table. You should be able to make all these connections. Okay, so let's look at example 2. In example 2 it says, for a certain time Lucy jogs up a hill at a steady speed. Then she runs down the hill and picks up her speed. Which graph accurately represents the situation? Okay, so the first step is to identify key information that is given. Then, at first it says that she jogs at a steady speed. So that means that her speed is not changing. If you notice, we have a graph with speed and time. A steady speed means it's staying straight. It's not going up, it's not going down, it's just a straight line. Okay, so right away I can already see from these three graphs which one it is. Why? Because there's only one that's showing a steady speed at the beginning, which is graph number 1. Okay, so at first she jogs at a steady speed, so she does not increase or decrease her speed. So she runs down the hill and picks up speed. So from there, since her speed is increasing, we should see it going up. And again, that's this part right here. Her speed is increasing. So her speed is going up. You could draw an arrow of what it would look like. Translate this information to graphical representation. So the relationship that we see here is in graph number 1. Okay, so I want you to go ahead and pause me and see if you can match one of these graphs to this table which has the height of an object and with time and feet. Okay, so from this table you should have been able to match it to graph 2. Why? Because if you look at the first one, it does say it's decreasing, but look at the way it's decreasing. If you start looking at the changes here, the first change is only by a little bit. It's like 4. And then it changes a little bit more, so a little bit more than 10, which is actually a change of 12. And then it's about 20. So every time the change is bigger, so it's becoming smaller faster. And that's not what this graph is saying. This graph is saying first it's a huge change going down, and then it kind of starts slowing down how fast it's decreasing by. And that's not what we see here. We see it starting off slowly, and then all of a sudden it's changing drastically more fast. Okay, so that's why we were able to match it up to this. Now, why not graph 3? Graph 3 would be sort of like where you have intervals for something. Like, for example, the first thing that comes to mind is like at the post office. From a certain weight to certain weight, a package will cost a certain amount of money. And then from a certain weight to a certain weight, it goes up to, $3 more or whatever. So that's kind of what graph 3 would be matched up to. In graph 4, it's saying it stays steady, then goes up, and then goes down, and that's not what we saw at all in this graph. Okay, go ahead and try this. Try it, pause it, see if you can match it to part B, the table. So hopefully you guys were able to match it. It went with graph 3. Why? Because if you notice, it's first in the first year it's at 22 cents, and then for about a period of 4 years it stays at 25. So that's where that line is. It stays at 25, and then it jumps up and it stays at 29 for about 3 years. It stays there, and then it jumps up. So it's continually going up, but it's staying the same for a certain amount of years. So that's why graph 3 is the one that makes the most sense. And that's it.